Now, there's only one way to get off diesel, essentially, and that is to go to methane gas. We're talking about reality. We're talking about what we can do today, what we could start to do next year. Methane gas comes in two forms. One is fossil gas, comes out of the ground, you know, those big wells that pump and pump and pump. And biomethane comes from rotting wastes, essentially. Although, because it is made from biomass, it can come from a lot of other sources as well. Right now, it's the waste that we're looking at. A few basics about biomethane. It is an exact chemical twin of natural gas. There is no distinction to a chemist between biomethane and natural gas. Two, it is produced by gases emitted by decomposing wastes, and these wastes, this is really key, these wastes are broadly distributed everywhere. Each one of us creates 4.6 pounds of waste a day. Times 365, someone do the math. That's a lot of waste. So, yes, here's our former sanitation commissioner filling in some crucial facts. So all of us, everywhere we live, are producing this waste, which means you can't, it's not like an oil field in Saudi Arabia. It is competitive right now, although for various reasons hasn't quite assumed its competitive position without subsidies. And there's a huge potential, I should say without huge subsidies, and there's a huge potential. Now, making biomethane, it's not just a question of capturing these wastes. Cow stomachs make biomethane. What we do when make methane gas. What we do when we talk about making biomethane is essentially imitating a cow's stomach. Now, that happens naturally in the landfill. You can recover the gas from the landfill. It's about 50% methane. Or you can put wastewater, cattle slurry, energy crops, slaughterhouse waste, park waste through digesters. Those are just plants that are more efficient managers of the anaerobic digestion process in landfills. Anaerobic digestion process, by the way, are these little tiny microbes that make the methane gas. So these are living systems. This isn't mechanical, it's chemical and biological. You have to keep these little creatures alive in order for them to produce the methane gas. Hence comes a lot of tricky engineering, but which we've more or less solved. The important thing here, though, is that to go from this digested gas to what you can put in an automobile, you have to upgrade. That is, you clean it. You strip away the carbon dioxide, essentially, cleanse it of all the toxins, and then you're left with methane that's good enough to drive on. Why biomethane? A little context. It drives you farther per acre of fuel crop if you should choose, as the Germans do, to make biomethane from fuel crops. I'm not going to go into all the details because of time, but let's just say you want to put an acre of land into some kind of crop to drive your car. You could find the crop that would give you more miles per acre if you turned it into biomethane than you could find the crop that would turn into any number of miles with any of the other biofuels. So that's a pretty big advantage. It also has the lowest CO2 emissions. There's a term now that's being increasingly used, eCO2, which means the equivalent. We're measuring things. The unit of measure is carbon. And emissions of greenhouse gases on a lot of fuels. Here's petrol over here, a diesel. This comes from the United Kingdom. Lowest biogas, it comes from, emissions is biogas from waste. Same thing from California. California just passed a low carbon fuel standard, and they show that CNG, which is a compressed form of biomethane from landfills, is only 11% carbon intensity compared to the 95% range of gasoline and diesel. And look where natural gas stands here. Here's natural gas. Here's biomethane. Why this difference? Because these guys are made from gases that would otherwise escape into the atmosphere. I know some of these points I can't explain fully right now. Why is it so clean? Look at this. It looks like a centipede. That's a diesel molecule. It's hard to burn that thing. You have to break it down and burn every one of those little carbon atoms and turn it into carbon dioxide in order to get the whole charge. What happens? Some of those little carbon atoms don't go all the way, and they hook up with just one oxygen, and they become carbon monoxide. Others don't hook up with any oxygen at all, and they come out as little soot particles. Hence the awful pollution that Brendan talked about. It's a lot easier with natural gas. That little carbon atom just burns so easily.